Howdy, this video covers solving systems of equations by elimination. So, elimination is a method of solving a system of equations. Wow. And it's very similar to solving for a variable of a simple equation, such as, given x minus 6 equals 4, we need to eliminate the 6 on the left side to get x by itself. So, in order to eliminate the 6, we need to add a positive 6 to both sides. Alright, so then the 6's will cancel and we're left with x equals 10. So same goes for eliminating variables with a system of equations. We need either the x's or the y's to have the same number but opposite signs, so that when we add down we'll get the same the variables will cancel. So when you add the variables will cancel. So simple example, given the system of linear equations solved by elimination. Let's go ahead and jump right on in. So for this one, we're going to go ahead and eliminate the y's. And we can do that because from the start, we already have the same number 1, and we have a positive and a negative. So when we add down, we'll get 2x plus 3x, which will be 5x. Y minus y cancels, and then equals 9 plus 16 is 25. So we're going to divide both sides by 5 to get x by itself, and you'll get x equals 5. So that's half your solution. Now we need to solve for y, and you can do that by plugging this x into either equation. I'm going to go ahead and choose the first one. So we're going to have 2 times x, which is 5, and then plus y equals 9. 2 times 5 is 10, plus y equals 9. And then to get y by itself, we subtract 10 from both sides. That cancels, and we're left with y equals 9 minus 10 is negative 1. Yay! And then that's independent since we have a solution. So, multiply once example. This one, we need to multiply one of our equations by a number in order for it to cancel. So again, we're going to cancel our y's. Now, in order to cancel our y's need to have the same number. So since we have a 4 here, then we also need a 4 there. And then our signs are good. We have a negative and a positive. So that's good. So what do we multiply this y by to get that 1 to be 4? We multiply by 4. So we need to multiply the entire equation by 4. Okay? So 4 times 2x will be 8x. 4 times negative y will be negative 4y equals 4 times 9 is 36. Then we're going to bring over our other equation. So 3x plus 4y equals negative 14. That's different font. Okay, and then let's go ahead and add down. So 8x plus 3x is 11x. Negative 4 plus 4 is 0, so it cancels. And equals 36 minus 14 is 22. Now we need to divide by 11. The 11 will cancel. We'll get x equals 2. So then we need to solve for y. So we're going to plug this x all the way back into our first equation. So we'll have 2 times x, which is 2, minus y equals 9. 2 times 2 is 4, minus y equals 9. And then to get y by itself, we're going to subtract 4 from both sides. Negative y equals 5. And then we need to divide both sides by negative 1 to get y to be positive. So then y will equal negative 5. And again, it's independent since we have a solution. Next, multiply twice example. Given the system of linear equations solved by elimination. So we have 4x minus 3y equals 25 and negative 3x plus 8y equals 10. And for this one, we can cancel the x's or the y's. Let's go ahead and do the x's this time. So in order to cancel our x's need to have the same number, different sign. We already have the different sign because that's positive, that's negative. But now we need the same number. How do we do that? Pretty simple. This one, we're going to multiply by this number. 3. And then this one, we're going to multiply by that number, 4. Because 3 times 4 is 12, and 4 times 3 is 12. So they'll both be 12, so they'll both cancel. Okay? So let's distribute that 3 on the inside. 3 times 4x is 12x. 3 times negative 3y is negative 9y. 3 times 25 is 75. 4 times negative 3x is negative 12x. 4 times 8y is 32y. 4 times 10 is 40. Now we add down. 12x minus 12x cancels. Negative 9 plus 32 is 23y. 75 plus 40 is 115. Okay, now to get y by itself, we're going to divide by 23. And we'll get y equals 5. There's one answer. Now we need to get the other. We need to get x. So plug this back into our original equation and solve for x. So we'll have 4x minus 3 times y, which is 5, equals 25. So then we'll have 4x minus 3 times 5 is 15, equals 25. Now we need to get rid of the 15, so add 15 to both sides. We'll get 4x equals 25 plus 15 is 40. Then to get x by itself, we divide by 4. And x equals 10. And again, it's independent. Now, fourth example, whatever. So given the system of linear equations, solve by elimination. So we have 12x minus 13y equals 2, and negative 6x plus 13 over 2y equals negative 2. Aw, crap, we got a fraction. Real simple. All we need to do is get rid of the fraction. So in order to get rid of a fraction, we multiply by the denominator. So for this equation here, we're going to multiply by 2 to get rid of that denominator. And then we can go ahead and figure out what we need to multiply by to cancel stuff out. So let's go ahead and get rid of it. Let's distribute that 2. We'll go ahead and get 2 times negative 6x is negative 12x. 2 times 13 over 2. 13 over 2 times 2. The 2's cancel, so we're left with 13. So then plus 13y equals 2 times negative 2 is negative 4. Then bring across your top equation. 12x minus 13y equals 2. Now, what do you want to cancel? X's or y's? Turns out they're both set up to be canceled. Wow, imagine that. So let's go ahead and cancel. 12 minus 12 cancels. Negative 13 plus 13 cancels. Equals 2 minus 4 is negative 2. So we have 0 equals negative 2, which is untrue. Therefore, since it's untrue, we have an inconsistent system, and that has no solution. I believe this is the last one. Yeah. Okay, so given the system of linear equations, solve by elimination. So again, we need to cancel x's or y's. So what do you want to cancel? Let's go ahead and do x's because we've been doing a lot of y's. So we're going to cancel the x's. And in doing so, we need to multiply by a number because we have positive 12 and positive 4. And both rules are broken. We don't have a negative, and we don't have the same number. So in order to get this number here to be negative 12, so it'll cancel with positive 12, we multiply the entire bottom by negative 3. And then distribute. So bring across your top, 12x minus 3y equals 6. Negative 3 times 4 is negative 12x. Negative 3 times negative 1 is positive 3y. And then negative 3 times 2 is negative 6. And now we can add down. And it turns out everything cancels. 12 minus 12 cancels. 3 minus 3 cancels. 6 minus 6 cancels. So we're left with 0 equals 0, which is true, meaning we have a dependent system, and it has infinite solutions. Okay, and that's all, folks. Thanks for watching. Don't forget to take your notes and do your work and come to class. Okay, bye.